Hey guys, I'm going to go over the solubility curve portion of the study guide. Now I posted a full solution key. It's posted on Canvas under the announcements tab, so you can go check that out. Alright, so let's get after this. Number one, it says identify the solutes in the graph above which are gases. What can the other solutes be? Okay, now for the gases are these guys, the ones that are decreasing. Okay, now why are those gases? And I'll put arrows so you guys can see. Now, those are gases because as we increase temperature, what happens to the solubility? The solubility decreases. So increasing temperature decreases solubility. Now, if we think about gases and their nature, if we heat up gases, let's take the example of soda. Okay, soda is made by saturating a solution, which is mostly water, with carbon dioxide. Okay, if we heat up the solution, we know that the gas particles are going to move faster and faster and faster, and they're actually going to exit the solution. That's why the solubility decreases as you increase the temperature. Okay, so gases are any of the decreasing lines. Okay, now what can the other solutes be? The other solutes are solids in liquids or solids in water. All right, now why is that? Well, now as temperature increases, what happens to the solubility? The solubility increases. Okay. And that makes sense, right? We can actually dissolve more solid in a liquid if we increase the temperature. That's because it breaks up that electrostatic force, breaks it up, and then we can dissolve more. Okay? All right. Next one. It says complete the following table. It says solubility of KClO3, that's potassium chlorate, with different solvent amounts at 10 degrees Celsius. All right, let me get rid of this. All right, and I'm going to do a different color. Let's do green. All right, so at 10 degrees Celsius, that is, let me get more stuff right here. Okay, it asks you how much can you dissolve, so the maximum amount you can dissolve in each of these. So the first one is how much potassium chlorate can we dissolve in 100 grams of H2O? Well, this chart shows us how much in 100 grams of H2O. So all we got to do, okay, so where's 10 degrees at? Got it. How much can we dissolve? The maximum amount will land on the line. Where's potassium chlorate? It's this line right here. So if you follow it, this is it right there. I would say, let's call it 8. Okay. All right. Now, let's move to the next one. What about in 200 grams of H2O? Well, you can't look up here. This chart only shows in 100 grams, but you got to think. Okay, well, if we can dissolve 8 in 100 grams of water, that means if we're using double the water, we can dissolve double the solute, or double the potassium chlorate. And then over here, if we use half, that means we can dissolve half, so it's going to be 4. Okay, all right. Now, the next one, number 3. You started with a saturated solution of NH3 and 100 grams of H2O at 10 degrees Celsius. How many grams of NH3 would bubble out of the solution if you raised the temperature to 80 degrees? Okay, this is a good question. I like this question. What you got to do is you got to identify a couple of things. All right. Let's do a different color. Let's do pink this time. Okay, we got to identify the first part. It says saturated solution, so we're looking at where it is at on the line. We're looking at NH3 in 100 grams of water at 10 degrees Celsius. So let's figure out how much you can dissolve at that specific amount. Okay, so at 10 degrees, we're looking at NH3. NH3 is right here, the decreasing line. At 10 degrees, it looks like 70. Looks like 70. All right, so let's write that down. 70 grams. Now, if we raise the temperature to 80 degrees, how much will bubble out of solution? We know that if we raise the temperature, gas is going to exit the solution. So how much gas can exit the solution? Well, let's look. At 80 degrees, where are we at? There's an H3 right here, right? Boom, right there. I would say that's around 15. So we started with 70, subtract 15, and that will tell you how much has actually exited the solution. That comes out to be not 63. I don't know why I wrote 63 on the study guide. Oh, that's because I said 78. Did I mess this up in the beginning? Yes, no. No, so the study guide's wrong. 70 grams minus 15 grams is going to be 55 grams. I think on the study guide I put 63 grams. I'll take a look at why I did that, and I will fix that for you guys. All right? All right, so on the next video, I will post 4, 5, and 6.